And thank you for introduction. And nice to meet you, everyone. My name is Shuji Yamazaki from Japan. Actually, this is my first time visit to Sydney. So before coming here, my wife told me to purchase the awesome souvenir for her. So I'll be happy if you have any idea and tell me that. So before starting, let me introduce myself in brief. I'm in SpaceBD and in charge of sales and marketing of space experiment, especially inside IHS. And my background is a researcher. So I have dealt with biomaterial and liquid biopsy and exosome before. So I'm now interested in expanding the space utilization in the field of life science research. And this is our team. SpaceBD is a startup in Japan. We are developing comprehensive services in the space industry. And also we have a strong relationship with JAXA. So we are the only company that has been selected by JAXA for all commercialization applications related to satellite launch and ISS use. This is the overview of a large business area of our company. Our business is divided to three parts. The first is space infrastructure business, and second is space utilization business, and the third is space education. In terms of life science, we are providing space experimental with utilization of ISS facility inside and outside ISS. For example, our customer expose their moths outside ISS to examine the toughness or survival ratio under the high and low temperature or strong radiation. And also protein crystal growth experiment for drug discovery research. And actually, this is the main topic of my presentation here. And the second is technical project management. I cannot tell in detail here because it is confidential, but we can support the development of life science equipment in space with taking advantages of the knowledge of life science and space. And third is space education. We provide protein crystal growth experiment as an education program to high school students. This is ongoing, and let me introduce this in brief at the end of my presentation. So from the next slide, I would like to explain our main service of life science, protein crystal growth service. This is a Kibo unit in ISS, and by experimenting inside the ISS, it is possible to verify the effect of microgravity while minimizing the influence of the outboard space, like your temperature or radiation, And there is some interesting characteristics on the microgravity. For example, substances are mixed evenly, like your water and the oil, and also float without a container. And there is no convection due to the difference of density, We are providing the space experiment with utilization of this phenomenon. Okay, this is our team of PCG. SpaceBD is the sole private partner of JAXA's protein crystal growth project on the ISS. And also, we have collaborated with Marwa Foods. Marwa Foods is a life science company, and they have a professional researcher of structure biology and protein engineering. So we can provide not only just space experiment, but also biochemical experiments on the ground. Okay, let me show how PCG experiment is used. This experiment is used by drug discovery research to know the structure of protein and drugs. If you have sick, there is something wrong with protein in your body, and drugs act on the proteins. So there is some various kind of forms of drugs and protein. So it is important to know the structure to match them each other. The knowing the structure allows the development of drugs that best act on the target. And here is a workflow of drug discovery research. In this field, we can provide at the 2 points. The first is structure determination of target protein, and the other is optimization of candidate compounds. Researchers determine and confirm the structure of target protein, and then do screening of candidate compounds from their library, and then confirm and verify the interaction between protein and the compound, including the protein and small molecules or protein and protein interaction. And this PPI, protein-protein interaction, is the trend of drug discovery research nowadays. Okay, here why microgravity is helpful for structure analysis. As I mentioned, in microgravity, there is no convection from density differences, and protein pressure can grow in quiet and stable environment, so that enables high quality crystals. And by analyzing this high quality of crystals, you can get structure information with high resolution. This left image, the bottom of the left image, is a crystal on the ground, and the right image is a crystal in space. The clustered crystal on the ground, you can get the very low resolution with this crystal, but you can get high resolution of crystal in space by analyzing this. Okay, this is a supplemental slide to know why hybridization is necessary for drug discovery. This is a comparison between the electron density of this resolution. In high resolution, it is possible to obtain detailed information about the pharmacophore, so you can design the drugs to match to the protein. But in low resolution, it is difficult to design the drugs because you cannot confirm detailed information about the pharmacophore. Okay, here is how space experiments work. In general, vapor diffusion method is often used in crystallization condition search, but we adapt the counter diffusion method to the space experiment. There are a number of cases where crystal quality has improved by changing the crystallization method from the vapor diffusion to counter diffusion. At the bottom of the slide, can you see the schematic image of this experiment? The first of all, protein solution is filled in the glass capillary, and also crystallization solution is filled around the capillary. And this solution was divided with a gel membrane, and then crystallization solution diffuses slowly into the glass capillary. So there is a graduation from the bottom to the top of the glass capillary. And this method has some advantages of crystallization. For example, in terms of condition, a wide range of crystallization condition can be explored at one experiment. And also in terms of quality, since the diffusion rate of the crystallization reagent is slow, so the crystal growth rate can be controlled, which suppresses clustering and can be expected to improve crystal quality. And also crystal stability is improved in the capillary as the solution never dries here. Our partner JAXA has lots of successful cases with Japanese university, and this data is publicly open. They have operated and developed more than 20 years, and they launched more than 1,000 projects before. This table is a comparison between the resolution on the ground and in space. You can confirm the resolution was improved after the space experiment. And at the 1.5 angstrom or high resolution, you can confirm the individual atoms with the structure. Okay, this is the slide for the value of high resolution. There is differences in electron density of reagent bound to protein molecules due to the differences in resolution. At 3 angstrom electron density is observed as clumps. So it is difficult to build an accurate molecular model. And up to 2 angstrom, a rough molecular appearance is observed from the electron density. And some researcher is satisfied at here. But with a high resolution of 1.5 or higher, it is possible to identify the positions of hydrogen bonds and water molecules, which are important for molecular design with high accuracy, and it leads to more efficient compound design. Okay, let me introduce an example of drug discovery related space experiments. This DPP1 is a protein for important enzyme for growing large drug resistant bacteria and periodontal bacteria. First, there are more than 4 million compounds of drug candidates here. And he narrowed down the chemical information of compounds that could bind to the target based on the 3D structure obtained from the first space experiment. And then narrow down to starting drugs candidate and then do in vitro experiment. And finally, he confirmed in second space experiment the binding mode between the protein and the compound could be verified by generating high quality crystals of the target hit compound complex. Okay, this is the overview of our services. We are providing ground experiments and space experiments with milestone settings. First of all, we receive the sample from customers and purify the sample, and then study the crystallization condition on the ground. And we have advantages in this purification method, and this is very important. So in many cases, resolution is satisfied only this process. And in that case, we don't recommend the customer to bring it to space. And also, if there is no possibility to crystallize on the ground, we also don't recommend bring it to space. So in case the customer wants more next step to get more higher resolution, we do crystallization testing and optimization in space experimental container, as I said, contact diffusion method, and then launch it to the space and get the crystal with high quality, and then analyze that on the ground. The customers only need to provide us with experimental samples and related information, so you can try very reasonable price and simple procedure. Yes, I'm reaching to the end of my presentation. Our service is not limited in KCG. We are expanding our service to the procedure before and after structure analysis. For example, we are collaborating with drug design, drug AI drug discovery company to provide drug design. And also, we adopt our knowledge cultivated here to other industry like agriculture or cosmetic or industrial enzyme. And in different forms of service, we're offering space experiment experience to high school students. And this is an example of our recent effort with the AI drug discovery company. By utilizing space experiments, it is possible to acquire detailed structure information that does not exist in existing libraries. Actually, it is difficult to obtain all information with space experiment, but simulation accuracy can be improved by using that information on some critical point. This is my final slide of education program. We are providing this program to high school students, and the students experience the flow of actual drug discovery research. So they not only just launch to space, from exploring crystallization condition to the analysis of crystals. So they fill the protein sample for space experiment by themselves. And after launching the sample and crystallizing it in space, it is returned to the ground and analyzed. And this program is ongoing now. And the sample will be launched at 18th November this year. There is a few cases in Japan now, but I would like to expand this to overseas in the future. Yes, that's all my presentation. I'm sorry not to have Q&A session here, but feel free to contact me. So I'm looking forward to collaboration with all of you. Thank you.